Hello, this is Joy Zeigler. Let's get started with our review for Exam 6 in Math 310. Problem number 1 says to solve by completing the square. R squared minus 6r equals negative 8. So we want to find the value of r that makes that equation true. And we are getting all of the variable terms on the left and the numbers on the right. And make sure that you have the terms on the left in descending power order, which we do. So this equation is already in a form that we can use. Our second step is to look at the lead coefficient of our squared term. R squared, the lead coefficient is 1, so we don't have to worry about it. If it were anything else, we would have to divide all of the terms by that number so that we ended up with 1 in front of our squared term. Okay, the next step is to take the coefficient of x, which is negative 6, of r, which is negative 6, and divide it by 2. So negative 6 over 2 equals negative 3. And then we are going to also square that number. Negative 3 squared equals 9. Now we're going to go back to our original equation and add 9 to both sides. R squared minus 6r plus 9 equals negative 8 plus 9. So that means r squared minus 6r plus 9 equals positive 1. Okay, if you look at the left side of the equation, you now have a perfect square trinomial on that side of the equation. You have r minus 3 squared. And you don't really have to factor this equation to figure out it's r minus 3. You just come up here and whatever that number is, you plug it in, r and then that number. It's half of what's in front of the r coefficient. So r minus half of of 6, and all of that squared, equals r squared minus 6r plus 9. So we've changed that to its factored form, and it's still equal to 1. Okay, I've cleaned up a little bit. Now we're going to use the square root property on both sides. We're going to take the square root, and we have r minus 3 equals plus or minus the square root of 1, which is 1. So we add 3 to both sides, and we get r equals 3 plus 1 or 3 minus 1. So r equals 4 and 2, and so that's our solution set. In problem number 2, there are two ships that leave the port at the same time. One heads south, the other heads east, and several hours go by. At that point, they're 170 miles apart. During that time, the ship traveling south travels faster, and so it covers 70 miles more than the ship traveling east. So let's draw a picture. East and south, we can say this is the port, and this is where the boat ends up traveling east, and down here is where the boat ends up traveling south. And we're told that the southbound boat travels 70 miles further than the eastbound boat. So let's call the distance the eastbound boat travels x, and then the southbound boat travels x plus 70. And we also know that the distance between the two boats at the end of that time is 170 miles. So we have a right triangle, and that means we can use the Pythagorean theorem which says one of the legs squared plus the other leg squared equals the hypotenuse squared. So when we rewrite that for our equation, we have x plus 70 squared plus x squared equals 170 squared. So the first term we need to multiply out, and we use our formula that says anything plus something else squared is going to be x squared plus 2 times x times 70 plus 70 squared. And then we still have that extra x squared. So simplifying further, we have 2x squared plus 140x, and then plus and 70 squared is 4,900, and 170 squared is 28,900. Okay, now we need to complete the square to solve this problem. So in order to do that, we get our variable terms on one side and our numbers on the other. That means we need to subtract 4,900 from both sides. And so we have 2x squared plus 140x equals 28,900 minus 4,900 is 24,000. So now we're set up, well, actually we're not quite set up to complete the square. We have a coefficient in front of the x squared term that is not 1. That means we need to divide everything divided by that coefficient. So we end up with x squared plus 70x equals 12,000. And now we're set up to complete the square. What we need is we need to know b over 2, which is 35, and b over 2 squared, which is 35 squared, equals 1225. So we add 1225 to both sides, and we get x squared plus 70x plus 1225 equals 12,000 plus 1225. And because of our b over 2 and b over 2 squared calculations, we know that the left side is a perfect square trinomial that factors to be x plus b over 2, which is 35, all of that squared. And on the right, we have 13,225. Now we can use the square root property, and we take both sides, the square root of both sides, and we get that the square root of the left side equals plus or minus the square root of the right side. So that means x plus 35 equals the square plus or minus the square root of 13,225, which turns out to be a nice clean 115. So all we have to do is subtract 35 from both sides and solve for x. So x might equal negative 35 plus 115, or x might equal negative 35 minus 115. The negative 35 plus 115 is 80, so we have x equals 80, and then the negative 35 minus 115 is 150, negative 150. But x cannot equal a negative number because we're talking about distances, so we can discard the negative solution. That means x equals 80. So what is x? X is the distance that the eastbound ship travels, which is 80 miles. And the southbound ship travels 80 plus 70, so that is 150 miles. And that is the solution. Problem number 3, we're going to solve this equation using the square root property. And in order to do that, we get our variable terms on one side of the equation and our numbers on the other. So we have 6x squared equals 792. Divide both sides by 6 to isolate the x, and we get x equals 132. Sorry, x squared equals 132. So now we apply our square root property. So the square root of x squared is the square root plus or minus the square root of 132. So we get x equals, and 132 is not a perfect square. So we need to see what factors we can take out of 132. You can go through this by dividing 132 by different prime numbers to find factors. One trick is if you add the digits, 3 plus 2 plus 1 is 6, and 6 is divisible by 3, that means 132 is divisible by 3. So you know you have 3 times 44, and 44 is 4 times 11, so let's write that. We have plus or minus the square root of 3 times 4 times 11. Now 3 and 11 are prime numbers. We can't pull them out, but 4 is a perfect square, so we can pull that out. So we can rewrite this, that x equals plus or minus 2 square root of 3 times 11 is 33. And so that is our answer right there. Okay, compared to the other ones, this is quite an easy one. We know that to complete a square, it says complete the trinomial so that the expression is a perfect square, and then factor it. So the key to completing it is we need to know what b over 2 is, which b is 22, so b over 2 is 11. And then we need to know what b over 2 squared is, which is 11 squared, which is 121. So we need to add 121 to this expression to make it a perfect square trinomial. And once we've done that, we can factor it by simply writing r plus b over 2, which is 11. So r plus 11 squared is our factored version. Okay, let's check our answer to see if that is correct. Is r plus 11 squared equal to r squared plus 22r plus 121? You can either use FOIL for this, or you can use that r plus 11, all of that squared is r squared plus 2 times r times 11 plus 11 squared. So that's what we are going to use right now. So that equals r squared plus 22r plus 121, which is what we want it to be, and so it checks. So our answers are right here. Number 5, use the square root property to solve the following equation. This is fairly straightforward because it's already set up for us. We have something squared on the left, and if we use the square root property, then we're going to take the square root of both sides, and we get that the square root of x plus 7 squared on the left is equal to plus or minus the square root of 450. So when we write that, we say x plus 7 equals the square root of 450. Now 45 is 9 times 5, so we know we have, let's use black, we know we have 9 times 5 times 10, and 10 is 2 times 5. So you can use a factoring tree to check this work, but when you do that, you see that 9 is 3 squared, and then you have this 5 and this 5, so you have a 5 squared, and then you have a 2 left over. So we can pull out the 3 and the 5, and we get that x plus 7 equals plus or minus 3 times 5 is 15 square root of 2. So now all we have to do is subtract 7 from both sides, and x equals negative 7 plus or minus 15 square root of 2, which you could then put in these brackets. Or you could write x equals negative 7 plus 15 square root of 2, comma, negative 7 minus 15 square root of 2. Either one of those would be fine. Here's another problem in which we're directed to complete the square. So here we have minus sign. That's new to what we've been working on. We need to know that b over 2 is 8 over 2, which is 4, and b over 2 squared is 4 squared is 16. So that we're going to add 16 to the expression, and that makes it a perfect square trinomial on the left side, and that factors to x minus b over 2, or x minus 4. And so this problem tests your understanding of what it means to complete the square. Moving on, we're going to use the quadratic formula, which says that x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. A is the coefficient in front of the x squared term, which is 1. B is the coefficient in front of the x term, which is negative 7. And C is the coefficient that doesn't have a variable next to it. But before we can do C, we have to rewrite the equation in standard form. So we would add 14 to both sides. Alright, this is the standard form of the equation, so we can see that C equals 14. Okay, let's plug A, B, and C in to our quadratic formula. Now we're ready to plug A, B, and C into our quadratic formula. So that gives us that x equals negative b, b is negative 7, plus or minus the square root of b squared minus 4 times a times c over 2 times a equals negative of a negative 7 is 7 plus or minus the square root. Negative 7 squared is positive 49 minus 4 times 14 is 56. All of that over 2 is going to be 7 plus or minus the square root of negative 7 over 2, which is equal to 7 plus or minus, and the negative sign becomes I, and then you break it up to put it in A plus BI form. So we're going to have 7 halves plus or minus the square root of 7 halves times I. This is the final answer. This problem asks us to solve for x, and we can either use the square root property or the quadratic formula. I'm going to use the square root property, so we need to get the x terms on one side of the equation, and that means to subtract 66 from both sides. And then we need to decide what b over 2 is. We'll just call it negative 17 over 2, and b over 2 squared. We'll give the negative sign to the 17. Okay, so what we're going to do is add 289 over 4 to both sides, and on the left that gives us just x squared minus 17x plus 289 over 4, and on the right it gives us negative 66 plus 289 over 4. Okay, on the right we need to multiply 66 by 4 so that we can have something over 4. In other words, we're getting a common denominator. So 66 is the same thing as 264 over 4, and then we still have the 289 over 4, and 260. The difference between 264 and 289 is 25. It's going to be a positive difference because 289 is positive and it's a larger number. Okay, on the left we can immediately rewrite this as x minus b over 2 squared, because that's what we do with a perfect square. And now we can apply the square root property to both sides. The left side of the equation becomes x minus 17 halves, and the right side, the square root of 25 is 5, and the square root of 4 is 2, and it's plus or minus, so we add 17 halves to both sides, and then we have to find two solutions for x. So the first one is x equals 17 halves plus 5 halves, which is 22 halves, which is 11. And the second one is x equals 17 halves minus 5 halves, which is 12 halves, which is 6. So the solution set is 6 and 11. You can go back and check that by plugging it into the original equation, plugging each of them in, or you could have solved this using the quadratic equation. In this problem, we have something, maybe a rocket, launched vertically upward from the ground, and you can calculate its distance at any given time by the formula d of t equals negative 16t squared plus 208t. Now, when you solve this formula, you plug time in seconds in for t and solve the equation, and you'll find out what d, the distance, is. The question, though, is what is the time when the distance is 550 feet? So we're given the distance and we have to find the time. The path of the rocket, or whatever object it is, looks something like this. It goes up and then it comes down. And if the distance of 550 feet is about here, then we're going to have the time here that it takes to get to the upward 550 feet and the time here when it passes 550 feet on the way back down. So we'll have two values of t. However, if 550 feet is right at the top where it touches, then we would only have one value of t. Okay, so we rewrite the equation with the distance being 550, and then that's equal to negative 16 t squared plus 208t. Now that is a quadratic equation. It has a t squared term and a t squared and a number. And a t term and a number. So we can use either the quadratic formula or the square root property to solve this. Let's go ahead and use the quadratic equation. Okay, what we want to do is get everything on one side of the equation, put it in a standard form, and set it equal to 0. And I think we should add 16t squared to both sides so that we get rid of that negative sign. So we have 16t squared plus 550 equals 208t. And then we subtract 208 from both sides, 208t from both sides. So then in order of descending powers, we have a quadratic equation in standard form. And so 16 is A, negative 208 is B, and 550 is C. The quadratic equation says that your variable is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So this is an exercise in being careful about your substitutions. B is negative 208, so negative b would be negative of negative 208 plus or minus the square root of negative 208 squared minus 4. A is 16 and C is 550. So we're dealing with some large numbers here. All of that over 2A, which is 16. So let's go ahead and calculate these numbers. Negative of negative 208 is positive 208 plus or minus the square root. Negative 208 squared is 43,264 minus 35,200. All of that over 2 times 16, which is 32. Continuing on, we get that t equals 208 plus or minus the square root of 8,064 over 32. Okay, let's go off to the side here and do a factoring tree for 8064. Turns out that 9 goes into 8064 896 times, and of course we're going to just put 3 squared here because that's what we're looking for, our squared terms. And 896 divided by 16 is 56, so 16 and 56 go together, and 16 is 4 squared, and we can stop there for that. And 7 times 8 is 56, and 8 is 2 squared times 2. Okay, so these are the various factors. So let's rewrite that. We have the square root of 8064 equals the square root of 3 squared, 4 squared, 7, 2 squared, and 2. So we can pull out 3, 4, and 2, and we're left with 7 times 2, so that's going to be equal to 24 square root of 14. So now we have that t equals 208 plus or minus 24 square root of 14 over 32. Okay, so continuing, we have 208 plus or minus. Now enter 14 and press your square root button, and then multiply that number by 24, and you get 89.8. All of that over 32. So let's say t equals 208 plus 89.8 over 32, or, so when you do that calculation, you get t equals 9.3 seconds, or t equals 3.69375, which rounds to 3.7 seconds. And that's the end of part 1. Now go on to part 2.